Learning objectives. At the end of this topic, you will be able to understand the angles made, parallel lines, and a transversal. Illustrate lines parallel to the same line. Illustrate angle sum property of a triangle. Introduction. Two lines in a plane that do not intersect or touch at any point are said to be parallel. They are always the same distance apart. What if a line intersects two or more lines at distinct points? A line which intersects two or more lines at distinct points is called a transversal. What angles are formed when a transversal intersects two non-parallel lines? Let's learn about these in detail in this chapter. Consider two lines M and N intersected by a transversal L. When a transversal intersects two lines, 8 angles are formed, 4 angles at each point P and Q respectively. Let us name these angles as angle 1, 2, 3, 4, 5, 6, 7, and 8. Angles 1, 2, 7, and 8 are called exterior angles. Similarly, angles 3, 4, 5, and 6 are called interior angles. Apart from these angles, we also have a pair of angles that are formed when a transversal intersects the two lines. There are 4 pairs of corresponding angles, angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8. Lastly, angle 3 and angle 7. There are 2 pairs of alternate exterior angles, namely angle 1 and angle 7, and angle 2 and angle 8. Similarly, there are 2 pairs of alternate interior angles, namely angle 4 and angle 6, and angle 3 and angle 5. Now observe angles 4 and 5 and angles 3 and 6 lie on the same side of the transversal. Thus, these angles are known as consecutive interior angles or allied co-interior angles. Let's see what happens when these two lines M and N are parallel to one another and draw a transversal to intersect them. On measuring the pair of angles with the help of a protractor, you will see all pairs of corresponding angles and alternate angles are equal. Thus, we conclude when two parallel lines are intersected by a transversal, each pair of corresponding angles are equal. This is known as corresponding angles axiom. Also, each pair of alternate angles are equal. Now let's calculate the sum of the measures of angle 4 and angle 5. We get 180 degrees. Similarly, on measuring, we find sum of measure of angle 3 and angle 6 is equal to 180 degrees. Therefore, we conclude that consecutive interior angles on the same side of the transversal are supplementary. Axioms. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This axiom is known as corresponding angle axiom. Axiom B, which is a converse of axiom A, states if a transversal intersects two lines such that a pair of corresponding angles are equal, then the two lines are parallel to each other. The corresponding angle axiom can be followed by a theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Let M and N be two parallel lines, and line L is a transversal intersecting these lines at two distinct points. We have to prove that each pair of alternate interior angles is equal, that is, angle 4 is equal to angle 6 and angle 3 is equal to angle 5. Let's begin with the proof. Sum of angle 1 and 4 and angle 5 and angle 6 form a linear pair. From the corresponding angle axiom, we know if a transversal intersects two parallel lines, in each pair of corresponding angle is equal. Thus, angle 1 is equal to angle 5. Therefore, equation 2 can be written as angle 1 plus angle 6 is equal to 180 degrees. Consider this as equation 3. From equation 1 and 3, we conclude angle 4 is equal to angle 6. Now let's prove the second part. From the figure, angle 2 and angle 3 form a linear pair, and angle 5 and angle 6 form a linear pair. Angle 2 is equal to angle 6, since angle 2 and angle 6 are corresponding angles. Therefore, equation 5 becomes angle 5 plus angle 2 is equal to 180 degree. Consider this equation as 6. From equation 4 and 6 we conclude angle 3 is equal to angle 5. Thus, if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. The converse of the above theorem is also true, which states if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Let's prove another theorem here. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Let M and N be two parallel lines. Line L is a transversal intersecting these lines at two distinct points. We have to prove that each pair of interior angles on the same side of the transversal is supplementary. That is, sum of angles 4 and 5 and sum of angles 3 and 6 is equal to 180 degrees. Now from the figure, sum of angle 1 and angle 4 is equal to 180 degrees. Consider this as equation 1. We know if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This implies angle 1 is equal to angle 5. Using this equation, 1 can be written as angle 5 plus angle 4 is equal to 180 degrees. Proceeding on to the second part, angle 2 plus angle 3 is equal to 180 degrees. Also, angle 2 is equal to angle 6 as they form a pair of corresponding angles. Using this equation, 1 becomes angle 6 plus angle 3 is equal to 180 degrees. Thus, each pair of interior angles on the same side of the transversal is supplementary if the transversal intersects two parallel lines. The converse of this theorem also holds true. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Lines parallel to the same line. Consider the theorem. Lines which are parallel to the same line are parallel to each other. Let's draw a line P transversal for the lines L, M and N. If a line L is parallel to M and a line M is also parallel to N, then a line L is parallel to N. This result can be extended to more than two lines. Angle sum property of a triangle. Now let us prove the theorem. The sum of the angles of a triangle is 180 degrees. This can be proved by using axioms and theorems related to parallel lines. Let ABC be the given triangle. Angle 1, angle 2, angle 3 are the angles of triangle ABC. We need to prove that sum of angle 1, angle 2 and angle 3 is equal to 180 degrees. Let's draw a line L parallel to BC through the opposite vertex A. From the figure, angle 1 plus angle 4 plus angle 5 is equal to 180 degrees. Since L is a straight line, consider this as equation 1. By construction, we've drawn L parallel to BC. This implies the pair of alternate interior angles is equal. That is, angle 4 is equal to angle 2 and angle 5 is equal to angle 3. Substituting the value of angle 4, angle 5 in equation 1, we get angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. A corollary follows this theorem. If a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the two interior opposite angles. Example: in the adjoining figure, AB is parallel to CD. Angle OFD is equal to 135. Angle OEA is equal to 40 degree. Find angle EOF. Through O, draw a line PQ parallel to AB. Mark the angles as shown in the adjoining figure. Now AB parallel PQ and OE is a transversal. Angle OEA is equal to 40 degree. Also PQ parallel to CD, OF is a transversal. Angle CFO plus 135 degrees equal to 180 degree. On simplifying, we get angle CFO is equal to 45 degrees. Now angle EOF is equal to angle EOQ plus angle QOF. We know that alternate angles are equal. So angle EOQ is equal to OEA and angle QOF is equal to angle CFO. So we write angle EOQ is equal to 40 degrees plus angle QOF is equal to 45 degree. Adding this, we get angle EOF is equal to 85 degree. In the figure, the bisectors of angle ABC and angle BCA intersect each other at O. Prove that angle BOC is equal to 90 degree plus half of angle A. Given, OB is the bisector of angle ABC and OC is the bisector of angle ACB of triangle ABC. To prove, angle BOC is equal to 90 degree plus half of angle A. In a triangle, the sum of three angles is 180 degree. In triangle ABC, angle A plus angle B plus angle C is equal to 180 degree. Dividing by 2, we get 1 by 2 angle of A plus 1 B2 plus 1 by 2 angle of B plus 1 by 2 of angle C is equal to 180 degree divided by 2, which is equal to 90 degrees. Bring 1 by 2 of angle A to the right hand side, then take 1 by 2 commonly from the second and third term in the left hand side. We get 1 by 2 of angle B plus angle C is equal to 90 degrees minus 1 by 2 of angle A. Consider this as equation 2. Angle BOC plus angle OBC plus angle OCB is equal to 180 degree. Angle BOC equals 180 degree minus angle OBC minus angle OCB. This can be written as angle BOC is equal to 180 degree minus 1 by 2 of angle B plus angle B. Consider this as equation 3. Since OB, OC are the bisectors of angle ABC, angle ACB. Substitute equation 2 in equation 3. Therefore, angle BOC is equal to 180 degree minus 90 degree minus 1 by 2 of angle A, which is equal to 180 degree minus 90 degree plus 1 by 2 of angle A. Solving this, we get 90 degree plus 1 by 2 of angle A. Prove that bisector of a pair of corresponding angles of two parallel lines are parallel. Given 1. AB parallel to CD. 2. PQ is a transversal. 3. EF bisects angle PEB. 4. GH bisects angle EGD. To prove, EF parallel to GH. Proof. EF bisects angle PEB. PEF is equal to angle FEB. That's equal to 1 by 2 angle PEB. 1. GH bisects angle EGD. EGH is equal to angle HGD is equal to 1 by 2 EGD. 2. AB parallel to CD. PQ is a transversal. PEB is equal to angle EGD. Alternate angles are equal. 1 by 2 angle PEB is equal to 1 by 2 angle EGD, dividing by 2 on both sides. PEF is equal to angle EGH, using 1 and 2. This implies EF parallel to GH, as corresponding angles are equal. Summary. Let's summarize the topic. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Each pair of alternate interior angles is equal. Each pair of interior angles on the same side of the transversal is supplementary. If a transversal intersects two lines such that either any one pair of corresponding angles is equal, or any one pair of alternate interior angles is equal, or any one pair of interior angles on the same side of the transversal is supplementary, then the lines are parallel. Lines which are parallel to the same line are parallel to each other. The sum of the three angles of a triangle is 180 degrees. If a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two interior opposite angles.